In today's lesson, we're going to talk about function behavior and some key characteristics of it. So the main things we're going to be concerned with, which is called end behavior, which is what are the very ends of the function doing. So we learned when we draw a graph of something, we're supposed to put arrows on the ends. End behavior tells us, should those arrows be pointing up or should they be pointing down for a given equation without having to graph the whole thing. Just by looking at the equation, we can determine should those arrows be pointing up or should they be pointing down. Then we're going to learn how to find zeros, which are the x-intercepts. We already kind of looked at that a little bit, but when we were looking at it a couple days ago, they were all nice, clean values, and so we're going to learn how to use a calculator to find them even if they're really messy. And then we're going to look for maxes and mins, and those are like the hills and the valleys of the graph, and we'll want to find those again with our calculator. So finding those zeros and maxes and mins are things that we'll be using the graphing calculator for. Doing them by hand is possible. It's messy to do algebraically, especially if those zeros are not nice numbers or if the maxes and mins don't happen on nice numbers. In calculus, we learn how to find maxes and mins by hand without a calculator, and then it isn't so bad, but we're not in calculus yet. So trying to do it algebraically is a pretty gross process without a calculator. So we're going to be using our technology to help us out with that. But the first thing, end behavior, we're going to do without a calculator. So end behavior, there are two main rules that we're going to use. The first rule is if the degree is even, and the degree means the highest power. So if the highest power present in the equation is even, then the ends are going to go in the same direction. If the degree is odd, then the ends are going to go in opposite directions. So like one end would be going up and the other end would be going down. The way I remember that is the word odd we can use to mean like odd numbers, like 1, 3, 5, 9, etc. 7, for some reason I skipped. And then we could also use the word odd has like another connotation to it, that when we could say like, he's a little odd. And it just means he's like different than we are, is really all that means, right? Because they probably don't think they're odd. But when we say somebody is odd, we just mean they're different than we are, or different than what we think normal should be, which we all think that we're what normal should be. That's kind of human nature. So the way I remember that is odd goes in different directions, or odd goes in opposite directions. Even will go in the same direction. The second thing we look at is the leading coefficient, which is the number that's in front of that highest powered term. Whatever number is in front of that highest powered term tells us about the right-hand arrow. If that number is positive, the right-hand arrow will go up. Positive for up. If that number is negative, the right-hand arrow will go down. And then we figure out what the left-hand arrow is doing by whether they're doing the same thing or different things. Okay? So in our first example here, what we want to do is locate the highest powered term, and that's really all we care about. We don't care about anything else in the equation, just whatever that highest powered term is. Then we want to look at the power. The power in this one is even, which means that our two ends are going to be going the same way. Either both up or both down. The number in front of that is a -1, and a negative tells us that the right-hand side will be going downward. And if the ends are going the same way, then that means that the left should also be going downward. So we have no clue what the middle of this thing looks like, but we know at the ends, the function looks like this. Okay? We don't know what happens in the middle. We don't know how many bounces and twists and turns it takes. Now this is quadratic, so it's really just a parabola. But we don't know. Sometimes it'll be a pretty messy equation with a lot of terms, and you won't have any idea what's happening in the middle. But by those two rules, we at least know what those arrows are doing on the ends. So in our next example, we look for the term that has the highest power, which may or may not be the first one in the equation, but we want to locate the one that has the highest power. The power on that is odd. which means that the two ends are going to go in opposite directions. Then the number in front of it is negative, which means that the right-hand side is going to go down. And if the right-hand side is going down and they're going in opposite directions, then that means the left-hand side is going to go up.
What's the power? What's the odd?
Since it's x to the third, 3 is an odd number. We're looking at what that power is, and is that power an even number or an odd number? As far as your answer goes, just this is completely sufficient. Just saying right down and left up. Or you could draw kind of a sketch. Again, we don't know what the middle of this thing is doing, but we know on the right-hand side it's going down, and on the left-hand side it's going up, and something's happening in the middle there, and we don't know what. But somehow it's connecting, and the left is going up and the right's going down.
Is the negative part, is that the first number?
It's the number in front of it, yeah. It's not necessarily the very first number in the equation, but it's the number in front of that highest powered term.
Oh, okay.
So for our next one, we want to locate the highest powered term. And in there we want to look at the power. And that's even, which tells us what? They're going to go the same way. And then we want to look at the coefficient, which is positive, which tells us what? The right goes up. Okay, so the coefficient always tells us about the right-hand side. And then we use the fact of whether they're doing the same thing or opposite thing to think about the left. So what is the left doing? Going up. So again, we don't know what the middle of this thing is doing, but we know both ends are pointed up and something's happening in the middle to connect them. You can either draw a sketch or you can just list them out. Okay?
So it's one saying including the answer?
No, we would just want to say what the right is doing, what the left is doing. And you can either write that with words or you can show it in a picture. I think this is our last one of this type. So we look for the highest powered term, which in all of these examples, it was the first one, but it doesn't have to be because they could be out of order. So you want to look through the whole thing and find the one that has the highest power, and that's the only part we care about. So on this one, our power is odd, which tells us what?
It's going to be opposite.
They're going to be opposite or going in different directions. And our leading coefficient is positive, which tells us that the right goes up. And if they're going in opposites, then that means the left is going down. So you can draw a picture or you can use your words. Either way is an okay way to give your answer. Now in the textbook, when you do these homework problems, the directions are going to look really confusing and overwhelming, and you'll be like, we didn't do that, because we're not. They use a notation. The directions will say something like, fill in the blanks, the limit as x goes to infinity, f of x equals blank, and your options are either positive or negative infinity. We're not going to talk about that. That notation actually isn't as confusing as it looks. But we're going to save that notation for a different math class if you go on in other math classes. For now, we're going to just do arrows up and down instead of talking about this lim stuff and infinities and stuff like that. So we're just going to say ups and downs. Okay? So don't worry about the directions and that messy notation there. When you do this portion of the homework, just do it like these examples. Tell me what the right's doing, what's the left doing, or draw me a sketch. Okay. The second part of our assignment then we're going to be doing on the graphing calculator. We're going to use our calculator to find the x-intercepts and the maximum and the minimum points of a certain graph. So what we need to do first is graph it. So the other day we learned to graph. We're going to go into our y equals. We're going to clear what is in there and type in our new equation. And it says graph it in a good window where we can see the maximum, the minimum, and the intercepts. In general, the standard window is going to be okay, but otherwise, I will show you how to adjust that. So once we get that graphed in there, what we're looking for are zeros, which is any place that it crosses the x-axis, or maximums and minimums, which are hills and valleys of our graph. And we want to find all of those things. So we're going to have multiple answers to these questions. So we're looking for anywhere that this thing crosses the x-axis. So I see 1, 2, 3 of those. We're looking for any high points, any hills, and I see 1 of those. And we're looking for any valleys, and I see 1 of those. So this is going to have 5 answers to this question. Okay. What I like to do is start as far as I can to the left and then work my way through. So I don't necessarily find all of my zeros first and then my maxes and then my mins. I just start on the left-hand side and work my way through. And there's a benefit to doing that, and I'll show you what that is as we start trying to find these things. So to find these things, step 2 says that on your calculator, you're going to press your second button and then your trace button, which is in the very top row. If you're using an app on your phone, stuff might be a little bit different. You can look around for it, or maybe I can help you find it. If you have a different type of calculator, it's going to be a little bit different too. But they should all have the ability to do this. So I'm going to press my second button. Which makes all my writing go away. Press second, and then my trace button is on that very top row of buttons. And the very first thing that we saw was a 0 or an x-intercept. So on the calculator, I'm going to choose choice 2 there where it says 0. So I can either go down to it and hit enter, or I could just hit the button 2. Then it's going to ask us a series of 3 questions. The first question says left bound. What this means is the calculator says, I can't look everywhere for this answer. You need to narrow it down for me. Where am I looking? So show me as far left as I would possibly have to look for this answer. So what we're going to do is take our arrows, and where this little blinking cursor is, I want to move that answer to the left of where the true answer is. So I'm going to take that, and I'm going to move it till it goes past that answer. It doesn't really matter how far past. I mean, we don't want to go way past it, but we want to go to the left past where that first answer is, that first x-intercept. And hit enter. When you do that, a little arrow shows up at the top saying, okay, this is my boundary. I'm not going to look anywhere further than that. The question then changes at the bottom of the screen to say right bound. So now it's saying, okay, that's as far to the left as I have to look. How far do I have to look to the right? So I'm going to take my arrows now and move that little cursor until it's on the right of that answer. Again, it doesn't matter how far. We don't want to go too far. In fact, we don't want to go so far that we would include like another answer, because then it's going to get confused and it's going to say, I don't even know which answer you're talking about now. So we want to stay pretty close to our answer and just kind of give the calculator a little bit of a boundary. When we're over there, I'll hit enter now. And then I can see at the top of the screen another little arrow showed up. So we get this kind of little bow tie thing that is saying I'm only going to look in this region for an answer. At the bottom of the screen, the question now says guess. You don't need to do anything for that. If you've given it good boundaries, then you don't need to guess because it already really knows. So I'm just going to hit enter when it says guess. And now at the bottom it says 0. It gives us an x value, and the y value should always be 0 because that's why it's called a 0. So our answer on this, we would need to round this off to a few decimal places. So my first answer for zeros is x equals negative 0.732. We don't need to give the y value because the y value should always be 0. That's why it's called a 0. Okay. So for our zeros, we just need to give our x value. If you're a little bit confused about that process, that's okay because we're going to keep on doing it for all the other answers. So we're going to get a lot of practice on it. That's all we need to do for that first one. That's not the end of the problem though, because that's just our first answer. We're looking for 5 answers in this problem.
Where did we like technically define it?
We found the exact place that the graph is crossing the x-axis right there. So the other day, we looked for those x-intercepts as well, but they were all nice, clean numbers. Today, they're not so clean, so the calculator is telling us the exact place that it's crossing there. So the next thing we're going to look for, if I'm kind of just tracing along this line, is the hill, okay, or the maximum. So that's the next thing we're going to find. The nice thing about this is all of these things are all in the same location in your calculator. So the same steps are going to apply for any of them. So I'm going to go and hit second, and then hit the trace button again. Everything's in that same menu. This time we're looking for a hill or a maximum. So I'm going to choose choice 4, which says maximum. It's going to ask us the same 3 questions. Now the reason why I like to just kind of move along the graph from left to right is now when it asks me for my left bound, I already am on the left. So it just kind of saves me a little bit of having to move that cursor around. I can just hit enter because it's already on the left-hand side. My little arrow shows up on top, and the question now changed to right bound. So now I need to move that little blinking cursor over to the other side of the hill and hit enter. And the other arrow shows up, and we can see now at the top we have this little bow tie, and it says I'm only going to look in this region for my answer. When it says guess, you don't really need to do anything about it other than hit enter. Then you'll have to think for a moment. At the bottom of the screen, we're going to get an answer. Now for maximums and minimums, we care about both the x and the y value because they could be anything. We need to be very careful with this particular x value here because notice at the end of it, it has this thing that says e-6. What does that mean? Scientific notation, which means negative 1.4 times 10 to the negative 6, or a whole lot of zeros in front of negative 1.4, which means that this is really pretty much what? 0. Okay, so anytime you see that e-6 at the end of it, it really is just 0. So our maximum is at 0, 2. For maximums and minimums, you need to give both the x answer and the y answer. And watch out for that little e in there, because that really means that it's 0. Some of your calculators might have even said 0, but mine was trying to be more specific. Yeah, and it could be a little bit different too, but it should still have that e in there, which means that it's really just 0. Yep. Okay. So for our zeros, we only need to give the x value. For maxes and mins, we'll need to give both the x and the y value. So then as I'm tracing along my graph, going down from the hill, I'm going to cross the x-axis again. So the next thing I'm looking for is another 0. So then I go back into the calculator, into that same menu, second, trace, and I'm going to choose 0, since that's the next thing I come along. When it asks left bound, the little blinking cursor is already on the left of that second crossing, so I don't need to do anything about that. Just hit enter. And then right bound, I move that little cursor over so it's past the crossing. Hit enter, and I get my 2 little arrows. For guess, just hit enter. And it gives me my 0, or my x-intercept is 1. Okay. So now, we already had a 0 before, which was like negative 0.7 something something, 32.
Yep.
And then now, we got another one, which is at 1. Okay. For our zeros, we don't need to give the y value because it should always be 0. As we continue moving along this line now, tracing it out, the next thing we would come to is a valley. On the calculator, we call those minimums. I'm going to come over here and press second, trace, and I'm going to choose minimum from the list this time. I'm already on the left, so I can just hit enter. I'm going to go past the valley, and hit enter. And I get my minimum. And remember, for maxes and mins, we care about both the x value and the y value. So my minimum is going to be at 2, -2.
If I got more than two, like I had, that's like I had 2 point something.
You can just round them off.
Okay. Does that just mean that
It
my
should be
sums are
really
different
close,
points?
though.
So, yeah,
I'm-
it was like 2.000.
Yeah. Yeah. Yep, some calculators try to be a little bit more precise. And then our last thing we're going to come across is one more x-intercept or 0. So I'm going to go second, trace, choose 0 from the menu. Hit enter because I'm already on the left. Move over to the right and hit enter. And hit enter for the guess. And it gives me our final 0 or x-intercept is 2.732. So we ended up with x-intercepts at negative 0.732 and at 1 and at 2.732. We ended up with a maximum at 0.2 and a minimum at 2, -2. Okay, so all 5 of those things would be your answers to this question.
Do we have to put them in the order?
No. Nope, it doesn't matter what order you list them in. Okay. All right. There is one more example of these problems in your notes, but I would really like you to just try that, and I'll kind of come around and try to solve any calculator difficulties that you might be having if it doesn't seem to be working right on your calculator. I'd like you to try this one out and just make sure that you can find all those things, and then you can go ahead and go forward to your homework. Make sure on your homework that you notice that some of them come from 6.2. The ones in 6.2 are those end behavior ones, and again, you don't need to worry about following the directions on those. You can just do arrows ups and downs. And then the 6.8 ones are these problems, and this is where you're going to need to be looking at graphs and estimating these maximums and minimums. Okay?
What about a calculator? Yeah, can I choose? Mine's been going along.